Morning, Algebra 1A students. Welcome to the video that covers Module 0202, Two Variable Equations. Before we get started, please make sure you have paper and pencil alongside of you, so that way you can take notes and complete the examples with me. So with two variable equations, we are going to first start with problems about consecutive integers. So we need to discuss what that term means. Anytime you hear a word problem that has the term consecutive integers, all right, consecutive means one after the next. So for an example, a set of consecutive integers would be like 4, 5, 6, because it's three different numbers, three different consecutive integers, one after the next. So if we have a problem that is asking us to find these consecutive integers, we can relate this with variables. So our first integer, so our 4, could be represented with the variable x. Well, then when we go to 5, well, that's one more than the very first integer. So we can represent that second integer with x plus 1. Then the third integer, well, we represent that with x plus 2 because it is 2 more than your very first integer, your x. And we can continue on with this pattern if we were finding 4, 5, 6, etc. consecutive integers. So for the first example, we know that we have the sum of 3 consecutive integers is 78, and it wants us to find the largest integer. Let's break down this word problem. I see a key word here, sum. What does sum mean? Hopefully, you realized that that means addition. Then I also see consecutive integers, so that's what we just took notes on up above. The next key word is is. What does is mean? It means equals. And what does it equal? 78. And then it wants us to find the largest integer. All right, well, let's set up our equation so that way we don't have to do a whole bunch of guessing and checking. All right, so we have 3 consecutive integers, so we can use these notes that we did up above. All right, so our very first integer is x, and then sum, so I'm adding to that. Well, my second number, if it's consecutive, would be 1 more than that, so my original plus 1. That would be my second integer. And then I have a third consecutive, so my original plus 2. And that is equal to 78. All right, now we have just created an equation that we can solve to easily find our integers without guessing and checking. Now, I have parentheses here, and I used the parentheses so that way we can recognize that x is our first integer, x plus 1 is the second, x plus 2 is the third. But if I look at my parentheses, is there anything that they're being used for, anything that I need to do? Nope, I don't have anything being multiplied, so I don't need to distribute. If I look on the inside, they're not like terms, so I can't combine them. So therefore, their parentheses are just there for grouping. They don't hold any meaning. So essentially, I can ignore them, or you could write them without the parentheses. All right. So when I look at this problem, we just discussed the parentheses. I don't have any exponents. I don't have any multiplication. All I have is addition. So let's make sure we add our like terms. So we have our like terms of our x's. Well, we have 1, 2, 3 x's. And then we have the like term of our constants, so our numbers, 1 and 2. Well, 1 plus 2 is 3, and that's equal to 78. Aha, now we have a two-step equation, which is what this module focuses on. So with our two-step equation, remember with equations, we're trying to isolate our variable. We are trying to get that variable by itself. So if I want to isolate this x right here, the first thing I need to do is get rid of anything that's being added or subtracted to it. So it's being added, a 3 is being added. Well, how do we move something to the other side of an equation? We do that using inverse operations. So inverse is another name for opposite. What is the opposite? What is the inverse of addition? I hope you said subtraction. So we're going to subtract 3 from both sides. And please make sure you guys show all of your work, because that helps prevent errors and helps you have good notes that you can reference while you're taking your quiz. So our 3x is not a like term, so that's why nothing happens there. We're just going to bring him down. But then 3 minus 3 is 0. So that's the reason we do the inverse operation, because that zeroes it out and it moves it to the other side of the equation. 78 minus 3 is 75. All right, I'm running out of room, so I'm going to rewrite it up here. So we have 3x is equal to 75. All right, now what do we need to do to isolate that variable? Now we need to move and get rid of the 3 so we can just have a single x. Well, what operation is going on between the 3 and the x? Yes, multiplication. Because one of the ways that we can show multiplication is by putting a number and a variable next to each other. Well, what's the inverse of multiplication? Division. So the inverse, the opposite of multiplication, is division. So if we divide both sides by 3, 3 divided by 3 is 1. And that's what I wanted. I wanted to be left with one single x. 75 divided by 3, 25. Before I move on, even though I have an answer, I found what x equals, let's make sure that we really answered the question. So the sum of 3 consecutive integers is 78. Find the largest integer. Well, I found x, but is x the largest integer? No, x is the smallest integer. That is our very first one. So if we want to label this, our x is our first integer, our x plus 1 is our second, and our x plus 2 is our third. What do you guys think we need to do to find the largest integer, find our third integer? Now we need to add 2. So if we take x plus 2, that represents our third integer, our largest integer. We can substitute, so we can replace 25 in for x. So 25 is the first integer, plus 2 more, that would be 27. That is our final answer. So the 3 consecutive integers would be 25, 26, 27. But the answer that it's looking for is the largest, 27. All right, great job, guys. Let's move on to number 2. All right, these next 2 examples are going to work with word problems where the equation has already been given to you and you just need to solve based on the information presented. Example 2, Natalie works for a florist. She charges $32 per day to make 12 bouquets. For every additional bouquet that she makes, she charges $1.40. The equation below represents this situation where E is her total earnings in dollars in a day when she makes B additional bouquets. So here we have the equation that it was talking about, and E is the total amount of money and B represents bouquets. It's always important for us to identify our variables and make that information stand out. So now the question says, how many additional bouquets will she have to make so that she earns at least $60 a day? Now, $60 a day. One of the reasons for identifying our variables is we need to know whether the $60 represents our variable E or B, because that will depend on how we use the equation to answer the question. All right, what do you guys think? Does 60 represent the E or the variable B? Yeah, it's our E, because E stands for the total earnings, and it says she's earning $60. As we look further into the question, it wants us to know, it's asking us how many bouquets. So this is the unknown. This is what we want to find. So that is our variable B, which is going to stay a variable for us to solve. All right, so we have our equation. E is equal to the $32 she charges plus $1.40 for each additional bouquet. So we know that she wants to make $60 in a day. So 60 is our E, so we're going to substitute 60 in for the variable E. But everything else about your equation stays the same because she still charges that $32 plus $1.40 for each additional bouquet. Now we only have one variable in the equation, so we can solve and to find our answer. We can solve and find how many bouquets she needs to sell to make that minimum of 60 bucks. All right, so just like before, we need to isolate the variable. So I would encourage you guys all to pause the video right now, solve this on your own, so then you can compare your work to mine after you resume. All right, if we are isolating our variable B, the first thing is we need to take anything that's being added or subtracted and move that over to the other side. So here we have a positive 32. What's the inverse of a positive 32? Yeah, a negative. So we are going to subtract 32 from both sides of our equation. And if drawing these guidelines helps you keep your work organized, please do it, because I know it helps me. So 60 minus 32 is 28. And then 32 minus 32 is 0. That's the whole reason we did the inverse, is that zeroes us out. It moved it to the other side. Plus 140B. All right, our B is almost by itself. We have that positive 140. So what's the operation? Yes, they're currently being multiplied. Therefore, the inverse of multiplication is division. So we are going to divide both sides of our equation by 1 and 40/100. So 28 divided by 1 and 40/100 is 20. And then 140 divided by 140 is 1. So that gives us our goal. We only have one single variable. It is by itself. So 20 is equal to B. Well, whenever we have a word problem, we want to label our answer. So what does B represent? We go back into the problem. B is additional bouquets. So B is equal to 20 additional bouquets. Now let's verify that we answered our question before moving on. So our question said, how many additional bouquets will she have to make? Is that what we found? Yes, it is. So check. We're done with number 2. All right, before we move on to our third and final example, I have a random fact for you guys. So did you know that if you were to keep a goldfish in the dark, eventually its pigment, its color, would turn to white. So it would no longer be orange. So goldfish in the dark would change colors eventually. Their pigment would adapt. All right, there you go. There's your random useless fact for the day. All right, example number 3, our final one for this video. The table shows the capacities of 2 pickup trucks that John, a landscape designer, uses for a project. The full-size truck has been contracted to carry 10 truckloads of soil to the project site. If X represents the number of truckloads that the short bed truck should carry to the site, and C represents the total volume of soil that is required in cubic yards, the equation below can be used to find X. So we have both an equation here and a table of information. So our question is, how many truckloads of soil should the short bed truck carry to the site if John requires a minimum of 45 cubic yards of soil for the project? All right, this question had a lot of information in it, so this is one that I'm going to need to read multiple times to make sure I fully comprehend the question and what I'm needing to find. So first, I want to interpret this equation that they've given me. So let's see, we have a 3.5. So where is that 3.5? Ah, right here. So 3.5 is the cubic yards for a full-size truck. And I see in the equation it's being multiplied by 10. Where did they get that? Ah, right here. The full-size truck has been contracted to carry 10 truckloads. So this information represents all of the data needed for the full-size truck. All right, then it's being added to 1.5x. Well, what's that 1.5? Ah, right here. So 1.5 cubic yards is how much a short bed truck can carry. And then it has the variable x. So I must not know how many truckloads. And actually, that does match the question because the question wants to know how many truckloads of soil should the short bed truck carry. So this, my unknown variable, my x, represents the short bed truck. And then it's equal to C. What does C represent? Here we go. C represents the total volume of soil. So C represents my total volume of soil. Do I have any information for that? Yes, if John requires a minimum of 45 cubic yards of soil for the project. So that's telling me that I know we have 45 cubic yards. So therefore, that is going to be substituted in for our C because we know that information. When I do that, I'd be down to one variable, which means it's solvable, and I can determine how many short bed trucks are needed. All right, so 3.5 is the cubic yards for the full-size truck, which we have 10 of, plus 1 5/10 is for the short bed truck, and that's still a variable x. We don't know how many of those we have, but our C, our capacity, our full volume, is 45. All right, when I look at this, I do have something that's being added. However, I also have some multiplication, so we need to make sure we always simplify before we start moving things to the other side of the equation. So we'll begin with 3 5/10 times 10, which is 35, plus 1 5/10 x equals 45. All right, if you haven't yet, guys, I would pause this because now this is very similar. This is a two-step equation. Try and solve this on your own, all right? That's how we learn, is by practicing on our own and then comparing our work and either getting it confirmed or finding out our errors so we can make corrections. All right, we need to subtract 35 from both sides because that is the inverse of a positive 35. So 35 minus 35 is 0. That zeroed out just like I wanted. So we're left with a positive 1 5/10 x equals 10. All right, I'm going to rewrite this up here because I'm running out of room. All right, what we have left is we're close, so now we need to divide both sides because that is the opposite, that is the inverse of multiplication. So x is equal to 6 66/10 repeating. All right, we solved for x, but let's go back and revisit the question to see what it was. All right, so my x represented the short bed trucks. Can I have 6 66/10 of a truck? No, we're not going to chop the back end of a truck off and it's still going to work. So we need to round to fit this problem. Would it make sense in regards to the story for me to round down to 6 trucks or round up to 7 trucks? Yeah, I would need to round up because if I am having this extra, it's not going to fit in that short bed truck. So I would need a 7th truck to be able to fit all of the cubic yards of soil. Yeah, dirt, soil. So our final answer is we would need x is equal to 7 short bed trucks. All right, thank you guys for joining and watching. I hope this has helped. If you are working on the O2 quiz and you have further questions, please reach out to myself, Mr. Masonoff, or Mr. Lazanti. We are here to help you. All right, bye guys.